Warm greetings, learner. Myself Dr. S. Senthilrani, Associate Professor, Department of EEE of Velamal College of Engineering and Technology, Madurai. In this lecture, we will be discussing about the applications of operational amplifier using diodes. The following are the topics for discussion: rectifier, clipper, and clamper. We'll start with the precision diode. So here you can find an operational amplifier's output. It is being connected with a PN junction diode D, and you can find that the inverting terminal, it is being connected to the diode's negative terminal. And here the input for this precision diode, it is provided through the non-inverting terminal. So let us have the discussion of its operation based on this diode's operation. So here assume that the applied input, it is positive. So when we apply a positive input, what will be the status of this PN diode? So here the PN diode, it will depend upon the input applied to its anode. So when the anode, it is receiving a positive input, the diode, it will be under on condition, and when the anode, it is receiving a negative signal, the diode, it will be under off condition. So here on and off condition, it means that the circuit, it will be closed or the circuit, it will be open. So assuming that the applied input, it is positive, so due to that positive in nature, the output of this operational amplifier here, it will be positive. So due to the positive nature, you can find that the diode, it will be under on condition. So when the diode, it is under on condition, a closed circuit, it will be formed, and this closed circuit, it will close the circuit from this end to the inverting terminal. So here the circuit, it will behave as a voltage follower. So as we know that in an voltage follower, the output, it is going to follow the applied input. So when we provide a positive input, the diode, it gets into on condition. So due to that on condition, here you have a closed circuit to be established, and that closed circuit, it is going to perform a voltage following operation, so that the output at this V0, it will be equal to the applied input Vi. The second case, assume that the applied input, it is negative. So when the input applied, it is negative, so due to that negativity, here you will find a negative signal. That negative signal, it will turn off this diode, so the circuit, it will be open. When the circuit, it is open, here you won't find any output. So here the output, it will be equal to 0. So this, it is due to the open circuited condition of the PN diode with respect to the applied negative input at its non-inverting terminal. So this is how the operation, it will be, and here the operation, it is decided based on the applied input at the non-inverting terminal of the operational amplifier. So with continuation to the previous discussion, we will find how the waveform, it is being converted. So as I mentioned that during positive half cycle, the diode, it will be under on condition. So that on condition, it will create a closed circuit. So that closed circuit, it is going to perform a voltage following operation. So here you can find that the applied input, it is entirely found as its output in the terminal of the operational amplifier. When the applied input, it is negative, here the diode, it will be under off condition. So due to that off condition, the circuit, it becomes open, and the open circuited, it will give the output V0 equal to 0. So again here for the positive, we are getting the same positive half cycle, and for negative, we are getting the output as 0. So the entire operation, it is controlled by the applied input. And next we will get into the discussion of a half-wave rectifier. As we know that a rectifier, it is an electronic circuit which has the capability of converting a bidirectional input into an unidirectional pulsating DC. So this unidirectional pulsating DC, it means that you will have the output with respect to one direction, whereas it won't be an entire DC signal. It won't be a pure DC signal. So that's why we say that a unidirectional pulsating DC. So here we are having and unidirectional output. So bidirectional input, it is converted into an unidirectional output. And as the name indicates, half wave rectifier, so here only one half of the cycle it is being rectified and the other half it is left as it. So here the output for the other half it is going to be 0 and one half alone it will be processed by this circuit. And very similar to an ordinary PN junction diode based rectifier, in operational amplifier also we have a similar rectification operation, whereas the difference it is an active element it is included for the rectification process. So here you can find that there are two diodes that are connected in this circuit, D1 and D2, which is used for performing the half wave rectification. And the applied input it is provided to the inverting terminal of the operational amplifier. So this means that whatever we get at the output, the inverted condition only it is found at this point. So here you are having an inverted output and that inverted output it will be reflected here. So assume that here you are provided a positive half cycle. For a positive half cycle, you will be getting the response in the opposite direction. If you find this figure it will give a clear image. So here for positive half cycle the response it is 0 and for negative half cycle the response it is positive. So this is because the applied input it is with respect to the inverting terminal. If you are applying the input with respect to non-inverting terminal, then you will have the output to be for the positive half cycle and for negative half cycle you will have the output to be 0. So that is the basic difference. So we will start again with the half wave rectifier circuit. Assume that the applied input it is positive. So this positive input what it will do? So this positive input it is provided to the non-inverting terminal and non-inverting terminal it is grounded by a R component or compensation. So here this positive half cycle it will turn on this diode. So the circuit here it becomes closed here and due to this positive cycle here you are getting a negative output. So this negative output it will open this circuit. So when this circuit it is open, you can find that the output terminal it is being disconnected from the operational amplifier and that's why you are getting a output as 0 for the applied positive half cycle. So under this condition D1 diode it is on and D2 diode it is off. The same way when we refer with respect to negative half cycle, here you can find that for the applied negative half cycle, here you are having a negative as its input to the inverting terminal and this negative cycle it will turn off the diode. So anode it is having a connection with the negative signal, so the diode D2 it will be under off condition and here this negative signal it will be converted into positive and this positive signal it is applied to D2. And this D2 it acts as a closed circuit and this closed circuit it is closed via the feedback resistor Rm. So here you can find that the circuit it behaves as an inverting operational amplifier. So this inverting operational amplifier it will amplify the negative half cycle that is applied. So here the picture it will give a clear image. For the applied positive half cycle we are getting the output as 0. Whereas for the negative half cycle, due to the inverting mode of operation, the negative half cycle it is converted into a positive half cycle. And this will take place only when the D2 it is off and D1 is off and D2 it is under on condition. So here this inversion it is because the applied input it is with respect to the negative terminal of the operational amplifier. If you are changing the input to non-inverting terminal, then only for this negative you will be getting the output, whereas that output it will be only in the negative direction. It will not be in the inverted mode of operation. So here you can find that only one half of the input signal it is processed at the output and that's why here the circuit it is referred as half wave rectifier. Very similar to the half wave rectifier, we will have a full wave rectification operation which is performed by the circuit full wave rectifier. Here you can find that there are two diodes, namely D1 and D2. So this D1 and D2 along with the two operational amplifiers A1 and A2, it will perform the full wave rectification process. as the name indicates, the full wave rectification, it means that both the positive and negative half cycle, it will be processed and it will be transformed at the output terminal. So by looking into the waveform, you will get a clear picture. Both the positive and negative half cycle, it is being processed and you are getting an unidirectional signal. So for the applied bidirectional signal, you are getting a unidirectional signal as its output. So here the circuit operation can be divided into two halves. What happens when the positive half cycle it is applied and what happens when the negative half cycle it is applied. So let us start with the application of positive half cycle. When positive half cycle it is applied, you can find that the positive half cycle it will travel in two directions. One direction, it will make this diode D2 to be under off condition because here we are having cathode. So this positive signal, it will have contact with the cathode. So it means this diode D2 it will be open. So when the diode D2 it is open, here you can find that this A1 it is not having its connectivity via the diode D2 to the A2 amplifier. So here this non-inverting terminal it will be grounded. Whereas on the other hand, the positive half cycle via this D1 diode, it will be closed circuit, and this closed circuit it will be having its connection with the inverting terminal of A2. So this is how the circuit it will be. So during the applied positive half cycle, the previous circuit I have shown here. So this diode it will be under on and this diode it will be under off condition. So due to this off condition, this entire portion it is being removed in this circuit. So it means that this region it is being connected to the ground and this input it is processed via this A1 and A2 and it is being connected by a resistor R. A1 and A2 it is being connected via a resistor R. The same thing with respect to negative half cycle, you can find that in earlier case we had a diode connected here. So this diode it will be open circuited because during the applied negative half cycle, the negative half cycle it will open circuit the diode which is connected here. So the diode it had an anode cathode direction like this. So this anode with the negative half cycle it will be open circuited and here we have cathode anode. So this cathode anode it will have a closed circuit. So the circuit it is being closed via in this direction. So this is how the circuit behavior it is going to be with respect to positive and negative half cycle. And the output it will be for the entire cycle, both for positive and negative half cycle, both the half cycles are processed and it is being presented only in one direction, and that's why we say that a rectifier as a circuit which converts a bidirectional AC signal into an unidirectional pulsating DC signal. The summary of this operation: when we apply a positive input, the status of diode D1 and D2 it will be on and off, and the role of the A1 and A2 operational amplifier, here it acts as an inverting amplifier, again here it acts as an inverting amplifier. So this inverting amplifier it is going to give a positive output. So this positive output through this inverting amplifier it becomes negative, and this negative when it is provided to an inverting amplifier A2, again we get the output as positive. Whereas in case of negative input, diode D1 it will be off and diode D2 it will be on, and here role of A1 it is an inverting amplifier and A2 it is a non-inverting amplifier. So this negative it will be turned into positive by this inverting action, and this positive it is carried out as such by the non-inverting operation. So this is the summary of the full wave rectification operation using an operational amplifier. And next we will start our discussion with the wave shaping circuit that is called as clipper. So there are two different types of wave shaping circuit. One it is called as clipper, another one it is called as clumper. We will start our discussion with the clipping circuit. So clipping it is nothing but some portion it is to be removed or it is to be cut from the input signal. So the output it will be presented in a wave shaped format, and hence the circuit it is also referred as a wave shaping circuit. So here you can find that I have shown a positive clipper circuit. So the positive clipper circuit where it receives its input with respect to the non-inverting terminal. So this circuit, it is being closed via a diode which is connected in the reverse direction, and the circuit it is going to act as a voltage follower circuit. Assume that the applied input it is positive, and here you can find that a reference signal it is also being provided with respect to the output signal, and here this reference signal it can be tapped as a positive or negative signal depending upon the connection. So here there are two signals that you can tap out. One it is a positive, the other one it is a negative. In this circuit I have used the positive terminal to tap the reference signal as a positive. So here Vin it will be compared against the V reference value, and depending upon the V reference value the circuit operation it is going to be. So here we will consider the condition Vin it is less than V reference. So when Vin it is less than V reference, the status of the diode it will be under on condition. The reason it is, here assume that Vin it is 5 and here it is 10. So this 5 what it will does, this 5 it will be provided as 5 volts at this terminal. So the negative it is receiving 5 volts. Whereas this 10 it will be provided as input to this anode. So here anode operation it is dominating the cathode, and hence the circuit it is going to be under on condition. So this it becomes closed circuit. Closed circuit it means that the circuit it is going to behave as a voltage follower. So what we have applied? We have applied a positive input. That positive input it will be entirely carried out at its output terminal. Assume that when Vin it is greater than the reference value. So here this value is going to be a fixed value 10. Instead of 5, if I am providing a 15 volts as its input, this 15 volt it will be applied at this point. So 15 we will have with respect to the cathode, whereas this 10 it will be provided with respect to the anode. So now here it is 15, on this side you have 10 as its input. So now cathode operation it will dominate the anode operation. So when positive value it is greater, here the circuit it becomes, the diode it becomes open circuited. So due to this off condition, the circuit it becomes open, and this open loop it creates a disturbance between the input output. So the entire circuit it becomes open loop, and the output it is tapped from the reference value. What was our reference value? We had 10 as the reference value. So that 10 it will be tapped out here. So the conclusion it is, you can find that when the input it is less than the V reference, you will have the entire input to be transferred with respect to the output terminal. Whenever your input it is exceeding the reference, the input it will be cut depending upon the applied reference. So you can get a clear picture with this waveform. I have taken a bidirectional signal of value Vin, and I have provided a V reference value with respect to the positive axis. It means that a positive V reference I have provided. So from that previous discussion, it is very clear that when the applied input it is less than the reference value, that value it can be reflected at the output because of the voltage following action. When the applied input is exceeding the reference value, you can find that the circuit it becomes open circuited. So whatever you have with respect to V reference, that value will be transferred here. So this is what you have found. To be simple, I can say that the value below the V reference you can find at the output terminal. Value above the V reference it will be removed or clipped off. And this circuit it is a positive clipper with a positive reference. The same circuit can be converted with a negative reference. Instead of taking a positive voltage as a reference signal, you can provide a negative voltage as a reference signal. So here the negative reference it is marked with respect to the negative axis. So the same condition, whenever the signal it is above the V reference, that it will be completely removed. So here you can find that these are the portion where the input signal it is above the V reference, that is completely eliminated. So this portion it is completely eliminated. The signal below the V reference, that alone it will be taken. So from this point to this point, the circuit it is going to be open circuited, and from this point to this point, the circuit it is going to behave as the voltage follower, and again the circuit it is open circuited. So this output it is a positive clipper with a negative reference. The same action it can be performed in the other direction, which is called as a negative clipper. So instead of processing the positive half cycle, here we will be processing the negative half cycle, and very similar to the positive clipper, here also the clipping action it can be done with respect to the negative reference or with respect to the positive reference. So the way we tap the output reference signal, the clipper can be classified as a negative reference or a positive reference clipping circuit. So here the negative clipper, very similar to your previous circuit, I have provided the input with respect to the positive terminal. There is a non-inverting terminal, and I have taken a negative reference voltage here. So this negative reference voltage I have connected to the output terminal, which is supplying the diode D also. The difference between the positive clipper and negative clipper it is, in negative clipper you can find that it is anode cathode direction, whereas in positive clipper you can find that the circuit it was a cathode anode. So here the reversal of diode in a positive clipper, it will convert the circuit as a negative clipper. So very similar explanation, it can be very similar explanation of positive clipper, it can be used for negative clipper. Here you can find that the positive signal it is provided. This positive signal it will be applied here. So the diode it is receiving, a diode's anode it is receiving a positive signal, and here you can find that a negative reference it is provided. So here you assume that here it is 5 and here it is 10. So when you have 10 as its input voltage, what you have? You are having sufficient negative voltage to the cathode, and here also you are having a sufficient positive voltage with respect to the anode. It means that the diode it will be under on condition. When the diode it is under on condition, this region it will be closed. So the closed nature, it creates a voltage following action to be established, and hence the circuit can be referred as a voltage follower circuit. So what happens in an voltage follower circuit? Whatever we apply here, the same signal it can be tapped out at this terminal V1. The other case it is when this signal it is varied, it is when it is less than the V reference value. Assume that here you are having it is greater than V reference value. Here you assume that the applied input it is some 15, and here the input it is some 10. So what happens to the circuit? When V in it is greater than the V reference, so when this V in it is dominating this circuit, here the circuit it becomes open, and due to the open condition, the circuit it behaves as an open circuited operational amplifier. So whatever you have provided here, the same signal it will be found at its output. So that's what I have summarized here. So here the summary says that VE above the V reference will be observed as the output, and below the reference value it will be cut. So there above the reference value was removed, here below the reference value it will be removed. So you can get a clear picture by looking into this waveform. So this is the reference line. We have taken a negative reference. So here above the reference line alone it will be processed, below the reference line it will be removed. In case of positive clipper with the positive reference, we found that above the reference it will be removed, and below the reference alone it will be processed. So here the reverse case, above the reference alone it is processed, and below the reference line it is being removed. The same case it can be carried out with a negative positive reference also. So here positive reference, just the reference point alone it will be varied. Here I am having a positive reference for negative clipping action. So the entire negative half cycle it will be removed. Along with that, a portion of positive half cycle it is also removed. So above the reference line alone it is processed. Below the reference line, this portion it is entirely removed. So this is all about the wave shaping circuit called as a clipper. Clipper it is nothing but an electronic circuit where a portion of a signal, input signal, it will be clipped off or removed at its output term. The other wave shaping circuit it is called as a clamper. The clamper it is also referred as a DC restorer. So here the DC restoring nature it is done with the help of a capacitive element that is provided in this circuit. So here the output of the circuit it depends upon the input value. It depends upon the processed operational amplifier's output, and it depends upon the reference value. So these are the three different voltages that determines the clamping action. So here the clamping action, you can get a clear picture by looking into its waveform. For a positive reference value, the reference value will be marked here. The entire cycle, it will be pushed above the reference. So here Vm plus Vm minus Vm, it is having an amplitude of 2 Vm. So this 2 Vm, it will be pushed above the reference value. When you have a positive reference, above this positive reference, the 2 Vm, it will be pushed. It means that this V reference along with this 2 Vm, it will be the entire output. In case of negative reference, the cycle will be pushed with respect to the negative side. So this summary, it will give a clear picture. When the applied input, it is working based on the reference signal. Assume that you haven't applied any input. The reference signal, it will keep the diode to be under on condition, which makes the circuit to act as an voltage follower. So the output, it is dependent on the V reference. When a negative half cycle it is applied with respect to its input terminal, that negative half cycle, it will charge the capacitor through the diode so that the output, it will be a maximum peak voltage Vm. And when a positive half cycle it is applied, the circuit, it becomes open. So whatever we apply here, that value will be entirely carried out at its output terminal. So for negative, charging it takes place. During positive, the circuit, it will be open. So this region, it will be open. This region open, it means that this signal, it will be directly connected to the output voltage. So here the output, it is nothing but your addition of this V reference, Vm and Vi, it takes as its output. So that's why you are having a shift in the DC level, and hence the circuit, it is called as a DC restorer. The same thing, instead of providing a positive reference, you can give a negative reference. So that negative reference, it will be marked first. So here the negative axis, it is marked, and below that negative axis, the entire signal, it is being pushed down here. So here you can find that the DC line, it is being restored with respect to the negative axis. So the summary of this discussion, it is, we have found that the operational amplifier along with the PN junction diode, it can be used for various applications, namely wave shaping, rectification and DC restoring.